Practice problems 12.5.2 on the 3D equation for a line. Well, this problem's a little special. We're not actually looking for the equation for a line. Instead, we're looking for the distance between a point and a plane. Now, ordinarily, this would be a pretty tricky problem to solve. Let's imagine this plane in space, and of course the point floats somewhere above it. I'm going to call the point A temporarily. It doesn't really have a label right now. And what I want is this distance. I want the perpendicular distance between the point and that plane. But finding this particular line that actually does this, I know that the normal to the plane will point in that direction. That is, it will be perpendicular to the plane. But the exact vector that actually connects that point to the plane is tricky to find. So what we're going to do instead is pick any other point that lies in this plane. I'm going to pick point B. And what we're going to do then is find the vector between A and B. And then we're going to project that vector onto the normal. Even though the normal may not rest in this position, it does indeed point in that direction. And anytime I project one vector onto another with the dot product, what I'll end up with is the length of that vector in that direction. So this will be AB in the normal's direction. And if I can find its magnitude, then that's actually going to be the distance between the point and the plane. So let's go ahead and do that. First, I'm going to need a point B and the normal. To find point B, I just need any point that lies in this plane and literally take your pick. What I'm going to choose is point B is going to be equal to 0, 0, negative 1. Why pick that point? Because it was easy to find. There's no other reason. Next, I need to find the normal. And of course, the normal's easy for this plane. The normal is the direction vector of the plane. That's 1, 1, 1. Okay, now I'm ready to get to work. What I want to do is locate first the vector AB. And that's going to run from A to B, so it'll be 0, minus 2, 0, minus 2, and negative 1, minus 2. I already have the normal vector, so now what I want to do is figure out what AB is in the direction of the normal. Keep in mind, that is what the dot product finds. So when I take AB and I dot it with the normal, remember, one of the things that finds is it finds the magnitude of AB in the direction of the normal, and it multiplies it by the magnitude of the normal. That means if I want AB in the direction of the normal, I just have to divide the dot product by the normal's magnitude. So that's what I'm going to do. AB in the normal's direction, which will be the distance that I'm actually after, is going to be the dot product between AB and N. And of course, AB is here and N is here. So that's negative 2, minus 2, minus 3. And I'm going to divide that by the magnitude of the normal. Of course, the magnitude of the normal is going to be radical 3. Now, because this is a distance I'm looking for, I really don't care whether this dot product is positive or negative. As a matter of fact, in this formula, we usually put absolute value signs around it to indicate that we don't really care whether this moves up or down. We're just interested in its size. So this is 2, 4, 5, 6, 7 divided by radical 3. And if you're into rationalizing your denominators, this is 7 radical 3 over 3. And that will be the minimum distance, that is the perpendicular distance, between our point A, 2, 2, 2, and this plane defined by x plus y plus z equals negative 1.